Current forecasts indicate that by 2027, AI will consume over 2% of global electricity and is already responsible for more than 10% of data center power. AI's energy impact comes in three phases. Development is the most intensive, followed by training, where energy scales with epochs, and finally, constant inference tasks. This energy consumption often forces utilities to burn more fossil fuels during peak times, increasing both carbon emissions and electricity costs. We will be using CodeCarbon into our pipeline to track emissions. The formula for calculating emissions with CodeCarbon is shown here. It accounts for hardware energy consumption, measured in kilowatt-hour, and multiplies it by the regional carbon intensity of the electricity grid for the duration of the computation. We will measure emissions across key life cycle stages: data preparation, model training, 20 epochs, and a single inference call. First, install CodeCarbon using pip install CodeCarbon. Once the installation is complete, we're ready to start tracking emissions. Next, we import the emissions tracker from CodeCarbon. Before starting data preparation, we initialize the emissions tracker and start it. Now place your data preparation code here. For example, loading data, pre-processing, or feature extraction. Once data preparation is finished, we stop the tracker to get the total emissions. This value represents the carbon emissions in kilograms of CO₂ equivalent generated during data preparation. You can repeat the same process for model training and model inference by creating separate trackers. This gives you a clear picture of how much carbon is emitted at each stage of your machine learning pipeline. Tracking carbon emissions helps us build more sustainable and responsible AI systems.